Ooh. Okay. I'm not muted, right?
No.
Okay. Can you all hear me?
Yeah.
Okay, thank you. Hi, Jefferson. How are you guys doing?
Hi.
Good. How are you?
I'm doing well, thank you. Did you have a good break?
Yeah, we did.
Awesome. Too short, right? Well, don't worry. Summer is around the corner. Have a good night, Phil.
Good night.
Take care, sir. Okay, so let's get started. Tonight we are going to cover chapter 5 of the text. Okay, here are the learning objectives. Tonight we are starting basically production and cost. There are a lot of concepts, but the logic is always the same. Like, in microeconomics, which basically this class is, managerial economics is basically application of microeconomics to business objectives and business problems, or managerial objectives, I should say, under constraints, whatever constraints the manager might be facing, usually cost constraints, as a business manager. So basically this is optimization. Remember last week we optimized the consumer's utility function. We realized when the marginal rate of substitution is equal to the ratio of the prices, we had an optimal solution. Or when the bang for the buck between two goods was the same, we had an optimal solution. It's different ways of saying the same thing with slightly modified algebra. Okay, so tonight we are going to use similar logic, but this time to the production problem. Like, last week we applied the optimization to the consumer's problem. This week we are applying it to the producer's problem. Basically in microeconomics there are two main entities, consumers on the demand side, producers on the supply side. Okay. Oh, that's the mouse, right? Yeah, let me borrow that. Hi, how are you? Can you remind me to get to take roll before we leave? Thank you. Okay, so the book sets this problem up nicely. Now, what is optimization? Mathematically speaking, optimization is basically finding the maximizing argument for a function under a constraint. In this case, we are trying to basically find maximum profit. Okay, to find maximum profit, we start with the best way will be to start with the definition of profit. So what is profit? Profit is basically equal to total revenue minus total cost, right? Now, total revenue by definition is price times quantity minus total cost. I'm going to put Q as a subscript. Why do I do that? It basically is alerting you to the fact that costs depend on quantity. For example, they might be something like Q squared plus 4Q plus 6. That's just the typical, let's say, cost function. Okay, there's a quadratic component, there's a linear component after that. So now this P is actually a function. That's basically your demand. That's your inverse demand. Okay, then you take your basically inverse demand function, multiply it by quantity, we treat it as a variable. And then the second part also depends on quantity. So your demand, inverse demand depends on quantity. That's multiplied by quantity, and then you subtract the second part, which is basically cost. Okay, so basically total revenue as a function of quantity minus total cost as a function of quantity. Now, what is the manager's problem? To find the quantity that maximizes that difference. Now, if you look at a graphical example, just to illustrate, here's our problem. So you have the total revenue function. For a linear demand function, let's say it looks like this. And then you have some cost function, and I'm just going to make it a quadratic. And the problem is to find the maximum distance, basically the maximum profit, which is the difference between these two functions. So this is your total revenue, this is your total cost. Now, if you were to do this with calculus, you will differentiate. You basically will find the derivative of the profit function with respect to Q. Since it has no other argument, like it's even redundant to talk about like partials. And then, once you do that, this will basically turn into marginal revenue. And the second part will turn into marginal cost. Those are basically derivatives of the revenue and total cost functions. And that difference needs to be zero, okay? Now, graphically speaking, that happens when, now the marginal revenue is the derivative of the total revenue function. It's like, let's say maximum profit occurs at point Q max, okay? That's the profit maximizing quantity. At that point, you have the marginal revenue, which is basically the slope of the tangent. And then you have the marginal cost. These two slopes are equal when the two are parallel. That gives you maximum distance, because anywhere else, when they're not parallel, the profit is either increasing. Let me draw the profit function here. I'm going to call it profit. Usually if you use the Greek letter pi, that would be shorthand for it. So maximum profit happens at this point, and at this point, profit is zero, right? Because at that point, total cost and total revenue are cutting each other. So basically, the maximum occurs at this Q, and then profits goes into negative after another Q. I could call it Q0, basically, or QO, okay? So this is the visual representation of this problem. Now, there's an alternative way to look at this problem, and that is from the perspective of hiring optimal inputs. Now, your production function or your quantity depends on basically your revenue, but also it depends on the inputs, right, that you hire. The more capital you hire, the more labor you hire, the more output you basically have, right? So you could actually think of this as a minimization problem. Given a certain level of output, you want to find the cost minimizing combination of capital and labor, which are your inputs. That is like in mathematics, they call it the dual problem, okay? Two sides of the same coin. I could have directly studied it as a profit maximization problem, but in the context on the left, I look at a cost minimization problem for a given level of output, okay? You have to be very careful here. People always miss this. Almost all managers miss this, which is kind of concerning, right? Most managers think the manager's role is cost minimization. Now, this begs the question, what is minimum cost for a business? Oh, that's for that one, right? Jefferson, can you hear me?
Yeah.
What is minimum cost for a business? Minimum possible cost. For any output level. Zero. Who said it? It's zero. But at what output does that happen? Exactly, because look at the cost function. It's a monotonic function, right? If you produce any output, it starts going up. There are no inefficiencies, right? So, but if you produce nothing, what is also your revenue? Zero. Zero minus zero is zero. Your profit is zero. So a manager's goal shouldn't be cost minimization, because if you take that for any output, right, just by itself, you should do nothing. But then that gives you zero profit, right? That's obviously not the manager's goal, right? A manager's goal is profit maximization, okay? So to form the dual correctly, you have to minimize costs for a given level of output, okay? Given output objective. If I want to produce a certain level of output, what is the corresponding minimum cost? Okay, that's how we go about the problem. Now, in microeconomics, if you look at your production function as a function of inputs, capital and labor, you have to make a distinction, like, the production process treats labor as a variable input, capital as a fixed input in the short run. But in the long run, it treats both as variable inputs, okay? So this kind of goes to the core of the economic theory, where, like, capital, unlike labor, is not an input you can change on short order. It takes time to build plants. It takes time to build machines, equipment, instrument. It takes time to build public capital, things like ports, highways, infrastructure, and so forth, okay? Whereas labor is basically the number of hours of work. You can change that in an instant, right? On a daily basis, you can change that. But for some businesses, acquiring a plant might be on the order of years, okay? Like if you're like Volkswagen and you have to build a new plant, that might take like 2 years. You can't just in one day like have a plant. Okay, so this kind of brings like short-run costs or the short-run production function, the long-run cost versus the long-run production function. Okay, here's some terminology. Output is synonymous with total product. Okay, now average product is basically your output divided by your input. So if I want to find the average product of labor, I take my output, which is my quantity, I divide it by the number of hours of work I hire. So it's not Android, it's Microsoft. Okay, so here's an example. Let's say like I hire somebody for 20 hours, and in those 20 hours, they produce 100 units of output. Okay, so their average product is 100 divided by 20, which is 5 units per hour. Okay. Now, marginal product, on the other hand, is basically the slope of the total product curve. Okay. Now, marginal product of labor is defined as change in total product of labor divided by change in labor. Now, let's say I have a production function. Here is my total product of labor, and here I have labor, right? Now, and my production function, let's say, is like this, okay? So my marginal product in this case will be the steepness or the slope of this curve. Like, for example, at this point, it'll be the slope of this tangent. It'll be literally the ratio of this to this. Basically, like, if you approximate it between these 2 points, it'll be literally the ratio of this to this, okay? Since the tangent is a line, it has the same slope everywhere, okay? So basically, by increasing my labor from 10 units to 12 units, if I'm attaining an output increase from, let's say, 100 to 120, right? What is the change in my output? Change in TPL, in this case, is plus 20, and the change in labor is plus 2. That ratio is going to be 20 over 2, which is 10, okay? So basically it's saying like, the last 2 units of labor on average produce 10 units, okay? So marginal is looking at asking the question, how much output did I get from my instantaneous hours or the last unit of labor I hired? Whereas the average is looking at the overall average productivity, okay? Here are some examples. I gave some examples, and my production function, these production functions. Now if you draw on the same graph, the average and the marginal, here's some, let me explain that graph a little bit. Okay, now, here's my production function, TPL. Here's my labor. Here's my basically the amount of product I'm getting. It's my quantity, basically. Here's 0. And as I keep hiring labor, this production function is increasing. First, it's increasing at an increasing rate. As I increase labor, the output is going up, but it's going up faster and faster. Up to this point, let's say that is 15 units of labor. After 15 units of labor, output is going up. I still climb. The trend is upwards, but it's going up at a decreasing rate. You know, like if this was a mountainside and you were riding a bicycle on it, you know, like you'll have to put in more and more effort up in for the first 15 miles. Okay. Then from 15 miles to 25 miles, you'll still have to put effort into it, but that effort will be getting smaller and smaller mile by mile, okay? So this is increasing from 15 to 25. Total product of labor is increasing at a decreasing rate. So in both cases, it's increasing, but first it's increasing at an increasing rate, then it's increasing at a decreasing rate, okay? Now, after 25, it's actually downhill. It is decreasing, but it's decreasing at an increasing rate, okay? It's starting to fall faster and faster, okay? So, so there are 3 areas, okay, you have to pay attention to. Now, remember, the marginal product is what? The marginal product, where is the marginal product actually minimized? Marginal product is the slope of the curve, right? Where is the slope of the curve the least? You know, the slope of the curve is the least when the curve is flat, right? You know, so this is the point at which marginal product is at minimum. So marginal product, at the beginning, it's increasing, reaches a maximum, right? So it has a maximum here, okay? So the marginal product increases, reaches a maximum, and then reaches 0 here. And after that, it's negative, okay? Now, how about average product? So this one is marginal product of labor. How about average product? Like, what is happening to average product? Now, average product, you know, average product, remember, by definition, is equal to total product of labor divided by labor, right? Now, let me pick up a point, random point. Let's say this is point A, right? What is average product at point A? Mathematically speaking. Jefferson, can you hear the problem and can you see it? Question is, what is the interpretation of mathematical interpretation for average product? For marginal product, it's just the slope of the curve. What is average product, mathematically speaking? It is the slope of something else, actually. Because remember, average product at point A is the ratio. Let's give numbers. We know like this is like something like 12, right? And let's say this is 24. So what is average product at point A? So average product of labor at point A is equal to 24 over 12, right? Which is 2, right? But what is that? Geometrically speaking, what is that? It also has a slope, actually, interpretation, but it's the slope of something else, right? Remember, what was slope? If I call this point B, and I went from B to A, right? What is happening to my output? It is increasing by 24, right? That is the change in my Q, basically, or my TPL, right? And what is happening to my L? The change in L is this distance, right? Remember, what was the interpretation of slope? Rise over run. So APL at point A is the slope of the line that connects it to the origin. That is by definition correct, right? Because it's basically the ratio of this to this by definition. Like, you know, you divide whatever output you have at point A by the labor you have at point A. But that is exactly the ratio of this to this. But that is just the slope of the line that connects it to the origin. Make sense? Okay, now let me draw for point A the marginal product of labor with a different color. Now at point A, on the other hand, the marginal product of labor is just the slope of the tangent at that point because it's the slope of the function itself. So at that point, marginal product is steeper, right? So that's why marginal product at that point is above the average product. You know, that's the inflection point. Now, the next question will be, where is average product minimized? where is the line that connects a point to the origin on the function for a given point, right? Which corresponds to a given amount of labor. Is the average product minimized? Where is minimum average product of labor? Now, the minimum marginal product occurs when the total product is flat, right? But where is minimum average product? Now, to do that, you can take two approaches. Like you could take the calculus approach, which we are not going to do in this class, because I don't expect students to know calculus. The second approach is a simulation approach, right? Point by point, I can draw lines from the origin to the point and see which one has higher slope, right? Because what was average product? It is the slope of the line that connects a point to the origin, right? So I can start at this point, connect the line to the origin, call this point, actually, let me use a different color. Blue, okay, thank you. Bye, Microsoft. Okay, call this point C, okay? Then there is point A, right? Then there is point D. Have you noticed what is happening to the slope of my basically plank that I set between the origin and the point? As I increase my labor, it's going up, right? It's becoming steeper. Then I pick up point E, right? It's even larger, right, at point E. Now, at the point where it's barely tangent, which is this point, let's call it point G, right? It reaches maximum. Because after that point, let's call this point N. If you connect it to the origin, the plank or the line has lesser slope. It's going down. The steepness of the line is going down. So the maximum of average product happens at this point. And not only that, at that point, since it's the tangent to the function, it's the same as marginal product, the value of the marginal product. So the maximum of average product of labor happens on the marginal product curve, okay? And then the difference is average product, since it's connecting to the origin, it never goes to zero unless the function cuts the L axis, okay? If the function cuts the L axis like this will be the point at which average product will be zero. Because then if you connect the point to the origin, it'll be flat. It'll have zero slope, okay? Because that was the definition of average product, right? So this is kind of explaining to you why this is the case. It's almost like a Picasso in mathematics, okay? It's kind of beautiful, actually. Like, being able to think through this problem teaches you a lot about understanding these concepts. If you can think through this graph I drew, like point by point, you're doing very well. I'll take off my hat to you. Okay. Now, here's a classical question. A manager faces this problem on a daily basis. What is the optimal amount of labor to hire in the short run? How would you approach that problem? Jefferson, did you hear that question? What is the optimal amount of labor to hire on a day-to-day basis for a manager? How would we approach that problem? It's an optimization problem. You have to find the amount of L that maximizes your objective. What is a manager's objective? To maximize profit. So the question then is, what is the profit maximizing amount of L in the short run? Okay. Now, remember, you learned a very valuable principle, the marginalism principle, right? What did the marginalism principle say? As long as the marginal benefit of an activity is greater than the marginal cost, the net benefit will be increasing. If the marginal benefit is less than the marginal cost, the net benefit will be decreasing. The net benefit will only be maximized when marginal benefit of the activity equals its marginal cost, right? If you apply that principle to this profit maximization problem, which is at what level of labor do we maximize profits, right? If you do that, you'll actually arrive at the correct answer, right? So what is the activity you are doing here? It's hiring, right? You are basically acquiring labor. So then the question becomes, as long as the marginal benefit of hiring is greater than the marginal cost of hiring, you should keep hiring. When the marginal benefit of hiring or acquiring labor or increasing L falls below the marginal cost, you should stop hiring. Okay. So now, what is the marginal benefit of hiring? Now, there are two approaches here. One is the algebraic approach, one is the graphical approach. Okay. Now, let's take the algebraic approach. What is the marginal benefit of hiring? When you hire an extra unit of labor, right? What does that labor bring in terms of profit? Exactly. So what is the extra quantity the last unit of labor produces? By definition, that's marginal product. So what is the value that person is bringing? The output they produce, which is the marginal product at that point level of hiring, right? If you multiply that by price. So let's say I just hired somebody for an extra hour, right? And for that extra hour, they produce 10 units of output, right? And those 10 units of output, I can sell at $3 each. So how much money did that person bring in that hour to me? 3 times 10. So they brought in $30. As long as that is greater than the marginal cost of hiring, I shall keep hiring, right? Now, here's the question. What is the marginal cost of hiring? What is the extra cost you incur if you hire somebody for an extra hour? We have a name for that, right? What do we call the extra cost of hiring somebody for an hour? You have to pay them the number of dollars we pay somebody when they work for us for an hour. What do we call that? The wage. So the marginal cost of hiring is the wage. The marginal benefit of hiring is basically what we call the value marginal product. And you have said it exactly correctly. It's basically price times marginal product of labor. So let me write that in a little more detail than it's on the board. So what is the marginal benefit of hiring? That we have a name for it. I shouldn't even call it equals, like, it's just by definition, that's what we call it. It's called value marginal product of labor. And it's defined as price times marginal product of labor. That is the extra benefit of hiring. Okay. I want to be correct. Hold on. Actually, please work with me. Okay. Okay. So this is the marginal benefit of hiring. What is the marginal cost of hiring? It's the wage. As long as the marginal benefit is greater than marginal cost, if marginal benefit of hiring is larger than the marginal cost of hiring, right? Then what happens? The net benefit of hiring, right? What do we call the net benefit of hiring? The profit from hiring that person. So this is like marginal profit, basically. So this we could call marginal profit. What happens to it? It goes up. If it is the other way around, goes down, right? Now, that would imply my profit first goes up, then goes down. So where does the maximum of the profit occur? When marginal benefit of hiring equals marginal cost of hiring, then marginal profit equals basically I should say, hold on, let me say it nicely. Hold on. Actually, I should have said that. This is positive, not increasing. This is positive. Hold on, let me write that. Positive. So then marginal profit will be 0 and total profit will be maximized. AKA total profit will be maximized. Okay, total profit will be maximized. So a smart manager hires labor as long as the extra labor brings in more money than they are taking away in wages. Okay, so if I was working for a business, as long as when I hire somebody, they make more money in that hour I'm hiring them for that wage than I'm paying them in wages, I keep hiring, right? Now, remember, the more people you hire, you face the law of diminishing returns, right? People become less and less productive in an environment, right? As you keep hiring them. So what happens to the marginal product of labor as you hire more people? As you add more work hours to your business, it goes down. Why does it go down? What fundamental law dictates that? What fundamental law dictates the law of diminishing returns? Like, what is at the core of the law of diminishing returns? True, but what is bringing the scarcity? I like the second word you use, resource. What resource is causing that? Remember, this is a short-run decision, right? We are hiring labor. Capital is fixed. Capital is fixed. Remember, this building is capital, right? This classroom is capital. Can I keep adding resources to this classroom and think they're going to be as productive as the previous resources? No. There's a limit to the number of TVs I can put. There's a limit to the number of professors I can put in the same room at the same time. There's a limit to the number of students I can put in the room, right? Eventually, the process will become less and less productive, right? Unless I expand the capital resource, okay? If you have 2 rooms, I can keep being as productive. Like I could have in 2 separate rooms, 2 separate professors, more TVs, more resources. You could keep your productivity at the same level. It doesn't need to diminish as long as you can change your amount of capital. In that case, actually, your total product curve shifts up. Okay, for a given, as you change your capital input, your total product curve will shift up. Okay, now here is a linear production function, and we are going to minimize it to find the optimal amount of resources. Actually, what is the alternative like? There are different types of production functions you could assume. The first one is linear. The second one is Leontief. The third one is Cobb-Douglas, okay? What is the difference between these? The isoquants for these production functions will be different, okay? Now let's see those. The book starts with a linear production function and gives this example, like for example, if I hired 3 units of capital and if I hired 7 units of labor, how much output would I be getting? Just to illustrate how this function works, right? When you say 3K, it's 3 multiplied by K. When you say 6L, it's 6 multiplied by L, okay? And then you just add those up. Now, for a linear production function, what are the coefficients? What are 3 and 6? In general, what are A and B? They call them A and B, right? Yeah. What are A and B? When you differentiate this function with respect to K, right? The second argument disappears, right? So A is what? A is the slope of the function with respect to K. L is the slope of the function with respect to L. Sorry, B. B is the slope of the function with respect to L. And what did we call them by definition? The marginal products, right? So A is the marginal product of capital, B is the marginal product of labor, okay? Now, with Cobb-Douglas, you cannot do that because isoquants are L-shaped. There are infinitely many slopes at the minimum point, okay? So, but with Cobb-Douglas, you could differentiate the function with respect to K, in which case you'll get AK times A to the power minus 1, L to the power B. For L, you could do the same and get the second part. Now, I'm not going to assume you know calculus and know rules for differentiation. But what you are going to do is to take those as given, the form, and then apply them. Okay? I don't expect you to understand why this became, when I differentiated the total product function, right, for a Cobb-Douglas. Remember, what is the shape of the Cobb-Douglas? If you go back, this is Cobb-Douglas. So my Cobb-Douglas production function is basically K to the A, L to the B. Like sometimes it has a coefficient in front of it. Sometimes it doesn't, like it's normalized to 1. That is okay. So if I differentiate this, if I take changing Q basically, divided by changing K, right? My slope. Of course, you have to be careful. Like, you know, this is like the difference operator. In mathematics, I'm doing something that is kind of like not that scientific, right? You know, because I have to take the limits of this, make the del operator, right? But for purpose of this class, just humor me, okay? So this will be basically A, K to the power A minus 1, L to the power B. But if I differentiate that with respect to L, I'm abusing notation. Mathematically, I have to take the limit of this as K or L, the difference goes to 0, like, you know, just in the neighborhood, right? Because a function's curvature changes like instantaneously as you change points, okay? But that is like just limits, integrals, and calculus, and so forth. You know, for purpose of this class, it's totally fine. That's where it's coming from, okay? All you have to know is the form, and know that this is the marginal product of labor, and this is the marginal product of capital. Okay, that's it. They're the slopes of the production function with respect to capital and L respectively. Okay, now for a linear function, if you do it, you just get the coefficient individually. Okay, so the coefficient of capital is marginal product of capital, and the coefficient of labor is the marginal product of labor for the linear production function. If you have a Cobb-Douglas production function, this is what happens. So when you do your homework, do not automatically assume the function is linear or the function is Cobb-Douglas. The question will let you know, okay? You have to be careful. You can only apply the coefficients if it's linear. You have to apply this format if it is Cobb-Douglas. Cobb-Douglas have smooth isoquants, okay? You know, I don't think it's giving any, you know, basically, let me talk about that a little bit. The book doesn't talk about it. I don't want to torture you. Let me see if it does, I'll talk about it. It's kind of sad that, like, you know, they don't talk about the graphical representation of the problem they're looking at. Okay, so here is, actually, let me go to like a more general, like kind of, yep, right there. This is an Cobb-Douglas production function. Okay, let me talk about that a little bit. I wasn't going to, but a linear production function has isoquants that are shaped like this. Okay, so here you have K, here you have L. This is linear production function. Why? Because remember, the linear production function has this form, AK plus BL, okay? Now, let's say this is the output level for 10, and this is equal to 2, this is equal to 4, okay? If I fix this at 10, to write a function, you have to write the variable on the vertical axis as your dependent variable, your argument for the left-hand side of the equation. So I have to solve this for K. So in that case, I'll have 10 minus, why did I write B? I was going to write 4 because I'm just solving it for that specific amount. Okay, what is left? I just have to divide both sides by 2. Okay, this becomes 5 minus 2L equals K. Now that's my function. You know, so when L is 0, right? When L is 0, what is my K? It is 5. That's my intercept, right? And this is the slope. It's negative. Okay. So when k is 0, what is my L? So I put 0 here. 5 minus 2L equals 0. 2L equals 5. L equals 2.5. So this point is basically 2.5. That is my x-intercept. Okay. Now, this is just for the linear production function. If, of course, and this isoquant, you know, I had 10 before. Let me write that better. Q equals 10. Okay, that was the Q value. Don't think that is the intercept or anything, not to confuse you. That's why I raised it and I want to write it this way. So now let's go look at the Leontief production function. Of course, let me actually go back to the linear, like, you know, what happens if I increase the quantity to, say, 20? Okay, if I increase the quantity to 20, what will happen? Now, this will become 20, right? Let's write it actually. Let me just illustrate it. 20 equals 2K plus 4L. Now, 2K equals 20 minus 4L. K equals 10 minus 2L. Now, slope stays the same. It's -2. But the intercepts change. Okay? So when K is 0, L becomes 5. Okay? And when L is 0, K becomes 10. So basically, you get a parallel shift to the right. Okay? So this is for Q equals 20. So as you increase your output, you're basically, without changing the marginal productivities, you're basically shifting your production function to the right. Okay? Now, here's another question. What is the slope of the production function for a linear production function? Or what does the slope of the production function in this context represent? Any idea? What is the slope of the production function? In this case, it's -2, right? But what is -2? Now, -2, actually, if you do the math, you know, you'll realize, do a total derivative, do all kinds of things, whichever way you want to do it. It's basically the ratio of 4 to 2 and in negative. Okay? What was 4? 4 was the marginal product of labor, and 2 was the marginal product of capital. So what is the slope of the production function? It's the negative of the ratio of the marginal product of labor to the marginal product of capital. What do we call that? We call that the technical rate of substitution. Remember, like when we were studying consumption for the optimal point, when the marginal rate of substitution was equal to the ratio of the prices, you know, we had the exact same problem. In that context, you know, we had the optimum. Now here, the slope of the production function is basically the ratio of the marginal products instead of the marginal utilities. Okay? Now this is only for a linear production function. Let's go to a Cobb-Douglas production function. Now for a Cobb-Douglas production function, isoquants become shaped like this. They're no longer linear, okay? But the interpretation is still the same. What is the slope of the production function? Or the isoquants, rather? What does the slope of the isoquants represent? Just like in the case of the linear, they represent the ratio of the marginal product of labor to the marginal product of capital. What does the slope of the isoquant represent here? They represent the ratio of the marginal products of labor again to the marginal product of capital. It is still the technical rate of substitution. Now, here is the $64 million question. Economically, what is that? Remember, what was the marginal rate of substitution in the case of consumption? It's the rate at which exchange rate. Thank you. Thank you. Remember, like marginal rate of substitution was the rate at which the consumer wanted to trade the two goods. This is the rate at which the firm wants to trade the two inputs. Okay? If your labor is in my example, twice as productive, you will exchange one labor for two capitals. Okay? Let me go back just to illustrate with the numbers. Remember, this is -2, which is the slope of the isoquant, right? In both cases. So what is this saying? I'll only trade one labor for two capitals. Okay? For me to be able to give you a labor, you have to give me two capitals. Okay? That's exactly what it's saying. Same with for Cobb-Douglas. The only difference is, in the case of the linear, the marginal rate of technical substitution is constant. It is -2 everywhere. In the case of the Cobb-Douglas, that slope changes point to point. Like, let me illustrate. You know, like, for example, the rate at which you want to trade them, the marginal rate of technical substitution, is different at every point of the isoquant. So here's my K, here's my L, here's my isoquant. Let's say this is just for Q2 equals 200. Okay? Now, what is the marginal rate of technical substitution? By definition, it is the slope of the isoquant, right? Here, it is steep. When you have little labor, labor is very productive in this production function. If you computed the marginal product of labor from the formulas we got, when you have little labor, labor is very productive. And at that point, you have a lot of capital to get the same level of output, right? And capital is very little productive. So that slope in that case is very negative. What does that mean? I have to give up this much capital to get this much labor. That's the rate at which I want to trade. So you have to give me a ton of capital. If I was producing at point A, my exchange rate is very high. I need a lot of capital to compensate for my very productive labor. I love labor at point A. At point B, on the other hand, if you look at that slope, the marginal rate of technical substitution, which is the slope of the tangent for that point, is exactly the opposite. Because at that point, I have a lot of labor, but little capital. Remember, the law of diminishing returns says what? When you have little of an input, they're very productive. Okay? So if I have a lot of capital, but little labor, capital is very productive and labor is very unproductive. So the slope of this, if you take the ratio of this to this, you have to give me a lot of labor to compensate for this much capital. Okay, vice versa. You know, I'm willing to throw, like, at point B, labor away. Capital is what matters to me. Okay? So that ratio is very different between points A and B. And then points in between is kind of in between the two. Okay? So this is, like, in a sense, how much you value one good, one input rather, in this case, in terms of the other. In the past, when we were doing consumption, this is how much you had valued one good in terms of the other, in terms of marginal utilities. Here, it's all about production, like, you know, how much do I value capital as far as this marginal productivity is concerned in terms of labor. Okay? Now, we still have not answered the, I don't know, $120 million question, which is, at what point graphically or algebraically, two separate ways of looking at the same problem, is profit maximized? Remember, from the consumer's problem, what was the profit maximization condition? Sorry, utility maximization condition. Last week we learned that, or 2 weeks ago. Does anybody remember? What was the utility maximization condition for the consumer? There were two versions, right? We wrote two different algebras. One was like the bang for the buck version. One was the version when we had the marginal rate of substitution versus the ratio of prices, right? So we could write either, but in either case, so I don't want to write it because I don't want you to think like that's what we're covering tonight, okay? But just to motivate the problem, you know, when the marginal rate of substitution was equal to the ratio of prices, right? Ratio of prices was the exchange rate for the market. The ratio of marginal utilities, which is the marginal rate of substitution, was the exchange rate for the person. If the person and the market want to trade the goods at the same rate, then the person reaches maximum utility. The person will change his amount of or trade one good for another as long as the two are equal. Okay, the person has no control over the prices. We are assuming this person is not a big entity in the market. Okay, he's just a price taker. It's like, who's a price taker in a market? Me versus Walmart. Like, Walmart will not change prices even if I bought 5 carts full of goods. But if I showed up at Walmart and said I'm buying everything in the store, Walmart would probably give me a very good discount for everything. Okay, so we are assuming, like, I'm just average person. Even if I buy 5 carts, it's a drop in the bucket. Walmart is not going to bother changing prices for me. Whereas if somebody showed up with like 18 semis and said, I'm buying your whole store, I want to talk to a manager, the manager will be like upfront, like in like 5 seconds. Okay, different customer. Okay, we already talked about that. Basically, like, the marginal rate of substitution between these 2 points, like D to C, B to A. Like, I just illustrated at a single point, which is the more correct version, because this is just an average slope. Okay. Now, ISO costs. How about cost? We talked about the production side. Remember, profit is the difference between the revenue side, right, and the cost side. We have not talked about the cost side, right? So, remember, quantity goes into the revenue side for a given price, right? How about the cost side? Now, we have the exact same concept, but this time we are not talking about ISO quants. We're talking about ISO costs, okay? Now, an ISO cost will always be linear. Why? By definition, costs as a function of labor and capital are as follows. So total cost is going to be the sum of total cost from labor plus total cost from capital. Now here we are also assuming the firm buys inputs in a competitive market. This firm is not able to influence input prices. If you were a really big firm hiring inputs, you could actually negotiate with the union the prices. Okay? This is not the kind of firm that does that. This manager is not that big. Okay? When I hire somebody to do like contract work at a house, that person has a rate and it's a market rate. Like, like there's some wiggle room, but not much. Okay? That's dictated by the market, everybody coming all together. So that's why the labor cost is going to be the wage rate times the quantity of labor. That's the money you pay to labor. This is the cost of hiring labor. This is the cost of hiring. Are they using R? Yeah, they're using R. R times K. R is the rental rate for capital. It's the interest rate, basically, or the real interest rate that you pay to get capital. Because every time, in a sense, like you are thinking about capital as machine, equipment, instruments, and having the bank finance it for you, okay, at some interest rate less the inflation. Because next year you could sell it, it might have some less, and then you have to adjust for depreciation. Okay, now if you do all this math, now of course, at an ISO quant, you have to fix total cost, right? Let's say we fix total cost at 20. I'm hiring labor at, actually, let's make it 200, just better numbers. And I'm hiring labor at $10 an hour. And I'm hiring capital at, let's say, $50 per capital, okay? Same exact logic. I'm going to drive my ISO cost, right? I have to solve this for what? For capital, right? Because capital is on the vertical axis. So this is the ISO quant. Which ISO quant? Hope Douglas. This is ISO cost. ISO in Latin means in this context same. Okay. Now, so I solve this for capital. 200 minus 10L equals 50K. Then, oops, why did I do that? So I have to divide both sides by 50. This becomes 4 minus 10 over 50, which is 1 over 5, which is 0.2 L equals K. Okay. Now, here's L. Now, when labor is 0, my capital is what? 4. On the other hand, when capital is 0, right, 4 becomes 0.2L if you multiply both sides by 5, labor becomes 20. Okay? And if you take the ratio, what is it? It's the ratio of the prices of the two, right? What is this ratio? It's 1/5. Of course, negative. 4/20 is 1/5, right? And what is 1/5? Look from here. The price of labor, the wage, divided by the price of capital, R. Okay? Because the wage is 10 and the price of capital is 50. That is negative 1/5, which is negative 0.2. So what is this? What is the slope of the ISO cost? It's the ratio of the wage to the rental rate or the real interest rate. Now, but what is the interpretation? It's the rate at which the market wants to trade the inputs with you. So there's a rate at which you want to trade with the market, which is the marginal rate of technical substitution. It's the ratio of the marginal product of labor divided by the marginal product of capital. Because from your perspective, the prices are not mattering directly for your production. How productive the resources matter. Prices matter to you indirectly because you have to trade with the market to get them. But from the perspective of the market, all that matters is money. You know what I'm saying? There's somebody else on the other side trying to optimize their own problem against you. Okay? So now here's the, remember I was asking the $120 million question. What is the $120 million question? When is profit maximized? Now, when is profit maximized? Remember, for the consumer's problem, the utility was maximized when the marginal rate of substitution was equal to the ratio of the prices of X to the price of Y. Now here, the profit will be maximized in a similar fashion when, for a given ISO quant, your costs are minimized. Okay, so what do I mean by that? Let me illustrate graphically. If a firm wants to produce Q equals 120 units of output, right? What is the optimal level of hiring for that level of output, right? Let's say you decided through your profit maximization, you want to produce 120 units of output, right? All you have determined is what is the profit maximizing level of output. But for that, you have to do the profit maximizing level of hiring, because without hiring, you're not going to be able to attain that, right? So the two problems are like, one is an input to the other. So this is your profit maximizing output. If that is the case, your profit maximizing level of hiring will be at the intersection of the lowest ISO quant. Remember, I'll illustrate that in a second. As you move north, east, your quantity increases. ISO quants get larger, right? We showed that. But if you move northeast, your costs also increase. As you want to produce more and more, you incur more and more costs to produce that level of output. So what is this cost function then? It is the least amount of cost, because at any point on this ISO quant, you're able to produce 120. The question is, which one is the cost minimizing? Okay? You want to produce for a given level of output, the output at the minimum cost, because you already have to produce. Here, you can, at point A, you can produce 120. At point B, you can produce 120. At point C, you can produce 120. At point D, you can produce 120. The question is, which one is cost minimizing, right? Now, at point A, given the slope is dictated by the market, because it's the ratio of the wage to the rental rate, you know, at point A, this is the cost function that passes through it. And this cost is much higher than this cost, because as you move northeast, your costs get larger. So point A's cost is to the right of, or to the northeast of point D's cost. It's a higher cost, okay? Now, if you want to produce at point C, you incur even higher costs. It's worse, right? The only direction in which it makes sense to produce is to go as far for a given slope to southwest as possible. And that will happen at the tangency point. So what are the optimal level of hiring? Let's give an example. Let's say this is 10, this is 15. So a profit maximizing firm, once it determines it has to produce 120 units as the profit maximizing output, from the profit maximization problem, then given the market prices for the goods, actually inputs in this case, which is capital and labor, right? It has to produce at point D to maximize its profits from hiring. So point D is the cost minimizing level of hiring. At the same time, it's the profit maximizing level of production. Okay. So what is the profit maximizing level of output? If it is 120, the profit maximizing level of hiring is 10 and 15. Okay. Now, what happens if input prices change, right? Remember, what was the slope of the ISO cost? It was minus W over the rental rate. Remember, the slopes of these functions will always be the ratio of the argument on the horizontal axis to the argument on the vertical axis. For cost, the argument on the horizontal axis is labor. So for cost, the price of labor will be W, and the argument on the vertical axis, the input, is K. The price of that will go into the denominator. Same with isoquants. At the top, you will have the marginal product of labor, because the labor is on the horizontal axis. That's kind of like a easy way to remember, like, what the ratio is. Always look at what is on your horizontal axis. If I flip the axis, put labor here, capital here, everything will be reversed. Okay, this will be like R over W. Ratio will be reciprocal, the correct ratio. Okay, so in this case, what am I doing? I'm actually being able to buy more labor, right? That means the price of labor has decreased, right? The wage rate is lower. So if the wage rate gets lower, the profit maximizing point changes. Like, let's actually illustrate it here. Let's say I was operating on this ISO cost, and I wanted to produce this level of output, right? 120. What was my optimal point? It was D, right? All of a sudden, the price of labor goes down. For the same level of cost, I can buy a lot more labor, right? What happens to my optimal point? Now, my optimal point actually allows me to produce a lot more, okay? So the firm will automatically realize now labor is so much cheaper. It doesn't make sense to produce 120 anymore, right? You want to produce more. That's one of the motivations, like, when companies realize, like, they found like cheap labor or cheap inputs or cheap capital, they want to capitalize on that, because that's going to lead them to produce higher levels of output for the same level of cost. Because these two ISO costs cost the same. The only difference came from labor becoming cheaper. So if you were producing in a country where labor is cheaper, you outsource to an overseas resource. Now you can produce actually output equal to 200 for the same level of cost. If you produce 200 and you can't affect the prices in the markets, you make a lot more profit, because you can still sell those 200 units at the same price. Your revenue is much higher, okay? But your costs of hiring labor and capital are still the same. If your revenue is higher and your costs of hiring the inputs is the same, your profit automatically went up, okay? So you moved basically from point D to point E, the new optimal point. We talked about this. There are two ways of talking about it. Remember, like, when we studied the consumer's problem, we looked at it from two perspectives, right? In one, the slope of the indifference curve, which is the marginal rate of substitution, was equal to the slope of the budget constraint, which was the ratio of the prices of the goods, price of X divided by price of Y. We can do the same here. So marginal rate of technical substitution, in this case, is the marginal product of labor divided by marginal product of capital. Algebraically, when that is equal to the price of labor divided by price of capital, what do we have? Cost minimization for a given output. Or given Q. Where do most managers fail? I guarantee you, like, if I got a manager that went through, like, sometimes top schools, right? I've seen this very often, like almost always, right? Where did they fail? They remember the cost minimization part, They don't remember for a given output. Because remember, we had that argument, right? What's minimum cost? If any output goes, make output 0, right? Cost minimization only is the dual of the problem if you fix your output. If you only produce, if you minimize the cost for that profit maximizing output. You know what I'm saying? Because otherwise, you could not hire anybody. But if you don't hire anybody, you have 0 cost. But if you don't hire anybody, you produce nothing. If you produce nothing, what is your revenue? 0. 0 minus 0 is 0. Quite often, you see people like trying to get inputs that are the cheapest, right? Without thinking about the marginal product side. You know what I'm saying? Like you make this cheapest, you make this cheapest. The ratio stays the same, right? You cannot, like, here, like, unless you change your production function, right? You cannot change the left ratio. The only way you can change your left ratio is what? If you change your production function. And the only thing that can change that is what? Either the amount of capital you hire, right? Because remember, that as you move on the isoquant for the Cobb-Douglas, you can change that. Another way to change that is technology. You can literally shift your isoquants to different locations. Okay, so what is this left-hand side intuitively or economically, and what is the right-hand side? The left-hand side is the exchange rate for the firm. The right-hand side is the exchange rate for the market. The market is telling you, and if these are not equal, you cannot be profit maximizing, or you cannot be cost minimizing for a given level of output. Why? Because if I like labor more than the market, right? What am I going to do? I'm going to give up my capital. It's less productive relative to labor, right? And in return get labor, more labor. But as I hire more labor, which is relatively more productive at the beginning, what's going to set in? The law of diminishing returns. This ratio will move towards the market eventually. It'll actually hit it. The other way around, what does this say if it is smaller? That means I like capital better than labor. For that ratio to be smaller than the market, I have to value capital more than labor relative to the market, right? So what will happen in that case? I'll actually get capital from the market and shed my labor, because labor is relatively less productive than what the market thinks it should be, right? The ratio. My exchange rate is lower. So, but if I'm giving away labor and acquiring capital, as I hire more capital, what's going to happen? The law of diminishing productivity is going to kick in against capital, right? So the higher productivity capital is all of a sudden going to become relatively less productive than before. But what will that do to the ratio? If this goes down, the ratio gets larger and meets the market. Okay? Now, of course, we are assuming the right-hand side doesn't change. What assumption is that? I am too small relative to the markets in which I buy inputs. Okay? For example, I'm not a monopsony. I'm not the firm in town that hires everybody. I'm not Walmart. If I was Walmart in this town and Walmart was the only business, I can make people work for minimum wage. Okay? They don't have a choice. But if a new business opened, people had a choice, then I lose some of my power. Now I'm a kind of duopoly in hiring. If you're a monopoly in hiring, you're called monopsony. I guess you would call her duopsony. Okay? Oligopsony. I don't know if that term even exists. Okay, so what is point? This point is the profit maxima or cost minimizing, I should say, for output level 100 units. Okay, given the wage to interest rate ratio. There is this income effect versus substitution effect. I'm not going to get into that. It's just, we don't have even enough time to get into that much detail. So now, here is another perspective to look at costs. Remember, at the beginning, we said capital and labor are different. There are short-run costs, there are long-run costs. Short-run costs, we are going to call them variable costs. Long-run costs, we are going to call them basically fixed costs, okay? At least they are fixed in the short run. Now, if you look at your production function with that perspective, you basically see that your total costs are the sum of your fixed costs and variable costs. Now, fixed costs by definition are fixed. No matter what output you produce, they're constant at this level. Okay? They don't change. Like plant costs, like, once I build a plant for $2 billion, right? It doesn't matter what level of output I produce in it. That's still $2 billion. But my variable costs change, like, to produce more, I have to hire more labor and capital. Okay? Of course, in this case, variable costs we are assuming are short-run costs. In that case, I'm like hiring more and more labor. Okay? Fixed costs are basically the cost of capital, which is the plant in this case. Okay? So you could interpret fixed costs as the cost of capital, variable costs as the cost of labor. And in the short run, you can keep changing variable costs. Because remember, in the long run, all inputs are variable. If all inputs are variable, there's no fixed cost in the long run. You can change anything. You could have an extra plant. Okay, if I waited long enough, I could change the plant size. Okay, now my variable cost, remember, has the same curvature as the total cost. Why? Because I'm basically shifting it up by the amount of the fixed cost, which is the same everywhere. This distance between the two functions is always the same and equal to fixed cost for any level of output. Now, here are the definitions: average fixed cost, average variable cost. Those are just basically the totals divided by the quantity. These are the analogs of the products. There was the average product of labor, marginal product of labor, average costs versus marginal costs. Okay. Now, you have to be careful, of course. What is marginal fixed cost? If you took the derivative, exactly, if you took the derivative of a constant function with respect to its argument, what do you end up with? 0. Its slope is flat, right? Or its slope in this case is 0. It's not only a constant, it's just 0. Okay. So here's the dual of, remember my Picasso, mathematical Picasso, remember the average product and marginal product, and I will spend some time explaining why they are the way they are. Those graphs are the way. This is the cost analog. If you notice, the average variable cost cuts marginal product, or marginal cost cuts average variable cost at its minimum. Okay? The minimum of average variable cost is this point at this output. That occurs at that point, it's equal to marginal cost. Okay, they're the same value. Let me actually illustrate that. Okay, so I'm just going to draw the average variable or average total, one of them. Just let's draw average variable cost, right? So average variable cost is here, and then my marginal cost comes and cuts it at minimum. This is my marginal cost. This is my average variable cost. I could have done the same with total cost. It'll just be shifting up, but doing the same pattern. So at this point, what is my output? My output is 20. What is my marginal cost? It's on this axis, right? This is average total cost, marginal cost, average variable cost. They're all there. They're basically dollar values, per unit of output, right? Dollar per output per Q. Okay, and here's my Q output basically, or capital Q if you want to call it. If this is 10, right? What is the average variable cost of the 20th unit of output? It is 10, right? The 20th unit on average costed me how much? $10, right? I should say it this way. The first 20 units on average costed me $10. Better way of saying it, okay? Because how do you get it? You get the total variable cost, you divide it by the number of units of output, right? It's like class average. You add up everybody's grades divided by the total number of students, right? What do you do here? You, for that point, take the total variable cost and divide it by quantity. It turns out it's equal to 10, right? But what is marginal cost of the 20th unit of output? The last unit, which is in this case 20 at this point, that's also 10. So the marginal cost cuts average variable cost at its minimum. Okay, that's the point it's making. Now, why is that true? Here's an analogy. If I was adding a student, right? This is kind of the product analogy, but it makes the same point. If I was adding, let's say we have an average grade, right? In this class, I'm just making it up. Let's say the average grade is 80, okay? On an exam or some homework, 80. If I added an extra student, right? So the average is 80. I'm adding an extra student, which is the analog to marginal product, right? if that student's grade is more than the average, what will happen to the average? It'll bring it up. As long as the marginal is above the average, what will happen? The marginal will increase. On the other hand, if the marginal, the extra grade I'm bringing into the class by adding the extra student is worse than the average, it'll bring the average down. So if you look to the left of 20, between 0 and 20, which curve is above the other? The average is above the margin, or the marginal is below the average. If the marginal is below the average, what is it going to do to the average? It'll keep bringing it down. And that is true. All the way to 20, average keeps declining. Why? Because marginal is less than it, right? If the extra student joining the class, or if the extra output you're producing is costing less than the average, what will happen to your average cost? It'll go down. You know, if the extra output you're producing is costing more than the average, it'll bring the average up. So when you go above 20, you have marginal is above the average. If the extra output is costing you more than the average, it's going to bring the average up. That's why after 20, average variable cost is increasing, which proves the point. The minimum of average variable cost will happen exactly when the marginal cost cuts through it, okay, in this case. Now, sunk cost, that's another confusion managers have. You know, here it basically makes the point, let the bygones be bygones, right? You know, I have a plane, right? Payment to make. I lease the plane. I'm Delta Airlines, let's say. I have a monthly payment of $5 million to make, okay? It's almost like you buy a car, right? Now, you have to pay that $5 million regardless, right? It doesn't matter for your decision-making process, right? You shouldn't say, for example, let's say that month, you can only run $4 million worth of flights, okay? After you pay maintenance and all the costs, right? So here's a manager that knows what he's doing, and here's a manager that don't know what they are doing. The manager that knows what they're doing will not think about the 5 million, because you have to incur that regardless, right? If you, the question is, shall I actually take these flights, or shall I just stop because I'm going to make a loss, right? That is the wrong way of thinking, because you're going to make a loss in this case regardless, right? If you didn't take any flights, what is your loss? $5 million. If you took $4 million worth of flights, right? You made $4 million. What is your loss? $1 million, okay? So this is illustrating sunk costs don't matter. You have to pay the 5 regardless. You cannot say, oh, I'm making a loss, I'm not going to run the planes. Because if you follow that logic, your loss will be larger. Okay, it's not a matter of if you are going to make a loss. It's a matter of how big the loss is going to be. As long as you make some of your variable costs in the short run up from your revenues, you should still keep operating, okay? You know, you should not shut down in the short run. Now, here are some examples for algebraic forms of cost functions. You know, this has like, of course, I think this is like equals. It just has the dash, but that's supposed to be equal. So there are fixed costs and the variable cost. Variable costs, by definition, are the part of cost that depends on output. Fixed costs are the same for any output. In this case, the letter F indicates fixed cost, like it's some number like 150. It's basically the plant cost. It's the cost of capital. Now, here is another form. Oh, sorry. This is the marginal cost. This is basically the derivative. Now, if you take the derivative of this, you end up with this form, right? For this function. You don't have to know the calculus behind it. You just look for form when you're doing your problems. Now, here's a question. This actually kind of, in a sense, makes the point that fixed costs don't matter, right? When you make decisions, only marginal costs matter. Only variable costs matter. You know what I'm saying? Because when you differentiate to find maximums and minimums or optimums, right? For your minimum costs, what will happen? The fixed cost will go away. For the plane, the $5 million is irrelevant. You have to operate as long as you can make any of it. Okay? Whether or not you can make a positive profit depends on the market conditions. But regardless, as long as you can recover any of your payments in by running your operation, you should keep operating. Okay. Long run average cost curve. This is probably the most important cost curve of all, right? There is no cost function that is as important as this for a manager. What does this say? There are two ranges, or it could have been three, because it could have had this form. So it could have come down like this, then had a flat bottom and gone up. Now, the first part, what is happening to the long run average cost as you increase your output? It's going down. In the second part, it stays the same. In the third part, it increases. Here's an other confusion, like, across the board. Not only amongst managers, especially amongst policymakers, right? Like people say, how many of you know the price of solar panels? How much is a 100-watt solar panel? It is so cheap. I mean, it's almost like, I'm exaggerating. It's almost as cheap as water. Okay, you can buy solar panels right now for next to nothing. It's cheaper than you'll make more money actually if you put solar panels on your roof, especially if you can do it yourself. Like if you're handy, like you'll actually, of course, depends on your codes and stuff. Like, I'm sure the government probably will get involved, unnecessarily. But if you can, you'll actually make a ton of money on your electricity bill. How did that happen? Everybody was saying, oh, solar panels will never take off. The sad part is actually the public doesn't know about it. You know what I'm saying? And the policymakers are not really informing people, right? They want the utilities to still continue charging you the bigger bucks. Your solar panels probably will pay themselves off like in 5-6 years, and they'll last like at least 25-30 years, okay, with good exit capacity. Hopefully not zero at that point. So, why? Because the more solar panels you produce, the cheaper they become. That's called endogeneity. Like price of solar panels depends on how big the factory is or how much the market produces them. They're not fixed. Back in the day, when policymakers or managers were making those decisions, they never understood this. Who understands this better than anybody and has worked this to make hundreds of billions of dollars for his company and for himself, tens of billions of dollars? Elon Musk, right? Have you ever heard the term gigafactory? Musk's gigafactories, I think there are already like 3 or 4 of them, are the biggest factories in the world, right? The price of batteries back in the day, when the EV vehicles came on board, like the last 20 years, were really high. Even when Tesla started around like 10 years ago, a little more, the price of a battery was so high, you had to sell a car for $100,000 plus just to make a profit. You were not profitable. And he has actually just recently become profitable as a company. But all along, one thing he understood, if you make this many batteries, the cost you face is going to be this high, like it's going to be 10, let's say. But if you made this many, it's going to be like 2. So by just increasing the number of batteries you are making, you can make batteries cheaper. It's not a constant, it is a function of how much you produce. And Musk understood this. Not only did he understand it, he sold it so well to the stock market, to the original venture capitalists that invested in his enterprise. And he himself invested a lot of his money he made in PayPal. It's a testament to his genius, and he's not an economist. Like he understands this better than a lot of others who are sometimes economic policymakers, sadly. So economies of scale is the first part when the long run average cost is going down. The second part is constant returns to scale when long run average cost is constant. The third part is diseconomies of scale because long run average costs are increasing. Like, beyond that point, you shouldn't produce. Like in most factory production, it's really hard to hit the second and the third part. His gigafactory is the biggest factory by far in floor space in the world, or they are. Probably he can make factories 10 times the size without running into the second or the third part, but that will require insane investment, and there might not be enough demand to justify that. Okay, eventually maybe there will be. So in markets, that is the case. They are called natural monopolies, because the more you have a monopoly, the bigger they can make their factories for inputs, right? Because they will have all the capital or the whole market to themselves to justify even a larger factory, right? If all the cars in the world were made by Tesla, in theory, cars could become cheaper. But in that case, of course, he'll be a monopoly. He might call his price. So there's like the downside of monopoly. Monopoly can make things that small firms cannot make happen, but monopoly also has control over prices. They can make their price, like they can say my way or the highway. Okay, so there's a cost function for a, production function for a, cost function for a multi-product firm. I'm not going to cover this. I'm going to leave it at this, and I shall see you next Monday. Okay, any questions? Say what? Oh, roll, thank you. So, okay, how do we do that? Like, shall I take it on my laptop or? That'll be nice.